Hi guys, so this is going to be the first video in a series of tutorials about how to do some surface analysis. This first video will basically just make a complex surface with a brick pattern on it that we can use for later visualizations. So I'm going to start off by making this a plane surface. The origin that's 500 feet by 500 feet. Makes just a flat surface. I want to rebuild this surface so that I can have a few more control points in it, 8 in each direction, and I want it to have a degree 3 curve so it has more curvature. So if I type P on, it'll turn the control points on, and then I can use these control points to then distort the surface however I like. And moving these around. I'm not really trying to create anything other than just a more dynamic surface that might show some of these differences in curvature that I can use for analysis. Okay, so that looks relatively okay. You can tell that it's going to have some steep areas, some less steep areas. Okay, so I'm going to start grasshopper. I want to go ahead and bring this surface in. And then I'm going to hide it. Viewport so you guys can see that a little bit. And maximize this. Okay, so I basically want to subdivide this surface in a way that it creates this brick pattern. And so what I'm going to do is I'm going to use this surface as a domain. It has a U direction and a V direction. And I'm going to divide that up. So I'm going to divide the domain. I'm going to use this surface as the initial input of the domain. And then I'm going to divide it in U and V direction. I'm going to say divide it in the U direction by 28 and the V direction by 100. This gives me multiple different U and V domains that are going to form the subdivision of the bricks. So I can use an isotrim. This takes a surface and a domain and trims it to make smaller surfaces. You can see this has a tiling brick pattern. I actually want to make a more running bond pattern, so I want to shift every other row half a brick so that I can sort of make that pattern. So to do that, I'm going to dispatch this with the pattern of true false. So one row will go into the A column, and one row will go to the B column, and then I'm going to shift one of them and put them back together. So I can then get, since these are the domains that I'm separating out, I can deconstruct the domain, just one of them. And then I'm going to shift it over in the U direction. So this way is going to shift 1/2 brick length. So I'm going to take those numbers in the U direction and add this number and say shift it over 8 units. I'm going to do that for the U0 and the U1, which is the start and end of the U domains. Then I can stitch those back together. Construct domain 2. We shifted domains back together. Shift these down some. And if I plug this into here, you'll see that I get every other one, and they're actually shifted. So I need to weave together this one that I separated out and this one. So this is actually in the true false value. This is A is going to be true, B is going to be false. So I'm going to plug this one into 1, which is true, and 0, which is false, which would be this one. And they should share the same sort of pattern. I can then plug it in there. You see now I have the brick pattern where one side is shifted. Sort of running bond. I can adjust how far that's shifted if I want to make it more or less shifted. I found 8 units is somewhere in the middle, which looks the best. You can also see it's adjusting to the stretch in that surface, so it's not truly a brick pattern. When it gets into a smaller curvature, it actually makes smaller bricks. When it gets into more stretched out curvature, it does the same, and the bricks are also curving along with it. So it's mainly just an applied pattern, not actually brick pattern. So I am going to group this together. Call this brick pattern. So in the next video, we'll look at ways of analyzing the surface for drainage, runoff, and see how we can use that for analysis.